The Web Transport Protocol is slowly becoming a reality. Chrome has released support for it around a year, at least experimental support for it. And Firefox version 114 just a few days ago actually enabled support for the Web Transport Protocol. Despite this protocol and spec is not being finalized yet, it's still in draft mode. That means there isn't even a number for it. There is no RFC, official RFC number for it. It's just in draft mode. So in this video slash podcast, I'd like to talk about what is this Web Transport Protocol? What features does it have? What is it gonna, why do we need another protocol, right? What is it really? So if you're interested, stay tuned. So it's important to start with the basics, The web has been built as the standard for anything that shares web pages and documents and anything on the web, and HTTP was built for that. And it is simply designed for a simple request response. So always the client initiate the request, never the server. The server sits there, waits for a request, and it gives a response. But then we wanted more interactivity from the server. We came up with a lot of tricks. We came up with the idea of long polling, such that, okay, I'm going to send you a request and just stream the results whenever you have the response. It doesn't, you don't immediately respond to me. Hold that request until you actually have the response. We came up with another tricks of our server sent events, which is also another cool idea, where we send one request, but the response is infinite. It doesn't end, right? And we use transfer chunk encoding for that, and a specific content types to say, hey, event stream. It's like let's just send data. It's like sending a request, but an infinite response. It's a response that doesn't end. And we use that to chunk those response into logical frames that we interpret in the client as quote unquote events. Brilliant pattern, But still, we also needed a bidirectional communication, which HTTP doesn't provide. It's a request response. Server cannot just send us things like that. While you can still use these two techniques to build a bidirectional communication, it's not intuitive, That's why the WebSockets protocol was designed. WebSockets was designed as a bidirectional communication. It's a really simple thing on top of HTTP. And what we did was really upgraded the connection that we used for HTTP, and we used it as a raw medium to send data back and forth. Of course, the WebSocket has its own overhead, right? Such as it has the idea of frames, its own concept of frames, and that frames has certain headers, so there's an overhead that you didn't have before, right? When you use the WebSocket protocol, it's not much. It's like around 14 bytes, 10 bytes per frame. The other thing is the WebSocket protocol uses certain things that are just weird. That these are predates the TLS, because WebSockets was built in 2011, right? Even before that. So TLS was not a thing back then. It was, but it's not as dominant. So they had this idea called masking, which you have to do, and it's cryptographic information to avoid cache poisoning for proxies, which is basically non-existent problem with you as TLS, because if you're encrypting things, then you have an encrypted channel. Nobody can change anything, and nobody can intercept that. So masking and all this idea of unnecessary overhead at the client and the server, pair frame, that just adds unnecessary things, So there's like a little bit of overhead. Plus, WebSocket must be on top of TCP, because HTTP 1 and 2 is on top of TCP, right? So there's like certain limitations for WebSockets that, while great, of course we use it all the time, there's still something missing. Right? Well, of course, the HTTP protocol itself was evolved. HTTP 2 was invented to allow for the idea of streams, right? So instead of just having a TCP connection to the server and you send one request and you wait for that server, you almost serialize all the requests in one connection. What you do is you segment that connection into streams and you tag everything you send with specific frames. The idea of frames was invented also in HTTP2, right? So there's this concept of frames, and the frames will have an associated stream ID with it. So this way I can send technically any number of requests at the same time concurrently in the same connection, and because each are uniquely identified, each they have their own lane, sort of speak. Eventually they all kind of multiplexed into this one single wire, but the server can tell them apart, these packets. Of course, we as a human being, everything we introduce, we always add overhead, and often the sad part is like we don't understand this overhead, and this overhead is just eaten, or sometimes just forgotten or not mentioned at all. And I don't like that at all. I like to pinpoint the limitations, and you can call me a negative, if you will, but there's always a limitation in everything we introduce as a human being, right? And HTTP2 and HTTP3 is not any different, right? Because of these frames, because of this additional headers, the server and the client had to do new things they didn't have to do back in HTTP1, right? Because now this processing, you might say, who cares? We have into Ultra now, 128, 192 RAM and whatever, 52 core. Was that much? I don't think it was 52. But I understand, but we take these things for granted. We became lazy. We don't think about these things anymore. Like the cost of doing business. So regardless, this is just a rant. But regardless, WebSockets, HTTP2, HTTP3 solved many problems. I talk about all of this stuff in my backend engineering course. Shameless plug. Head to backend.husseinnasser.com. Learn about all these patterns and protocols in details. But then the WebTransport protocol, they kind of came in to solve a diverse sets of problems. It want to introduce flexibility to the user. I suppose this was maybe introduced by gRPC, from Google. gRPC came in and built its own protocol on top of HTTP2, such that it can use a stream, same thing, you have one connection but multiple streams. So you can create a unidirectional stream, you can create a bidirectional stream. So this stream is just a unidirectional, that means it's a request response, right? This stream is bidirectional, that means the server can send data, the client can send data, and so on, right? But they built it on top of HTTP2, and it's a very popular protocol. It's language agnostic. Is that the right thing to say? I suppose, because this supports many languages. You can use protocol buffer, so anything that supports protocol buffer, if your language supports protocol buffer, then you got gRPC, right? So, and it has support, so why it became popular, right? But then the WebTransport protocol, now we talk about that. gRPC doesn't work on the web, despite anyone who tells you it does. It does not. You have to use all these weird proxies and stuff like that, but it's not natively supported in the web. And the reason is because gRPC needs access to these low-level streams. It needs to manipulate the streams. It needs to, have low-level access to the HTTP2 API, which The web doesn't give you that, right? If you built yourself onto the Chrome or the browser, all you get is what? The fetch API, right? But that's it. You don't even get access to the raw TCP connection, or in case of HTTP3, the raw quick connection. You don't get access to that. You have APIs. You send a request, you read a stream of a response. And the browser takes care of which stream, whether it creates a new stream for you, whether it creates a new connection. It all does that by itself. You know? So as a developer writing JavaScript in the client side, you have no control over that. And that's why gRPC cannot be built natively in the browser, because it needs access to these low-level API. It manipulates stuff. It sends data on this stream and in certain ways. It has its own, deals with all stuff. The WebTransport protocol actually does all of that for you. Okay? So you can create a WebTransport session. And then in that WebTransport session, I'm going to talk about how in a minute. In that WebTransport session, if the server supports WebTransport, it will allow you, either the server or the client, to create a stream that is bidirectional, that is unidirectional, or get this, unreliable. I just want a stream of unreliable data. I want UDP. I want UDP on my browser. Can I have UDP on my browser? We never had that feature. Well, take that back. WebRTC. Remember that thing? WebRTC is kind of UDP, right? So that's the only UDP source that the web developer had, that anything resembles UDP. But with WebTransport, you can actually create a new stream as a client or the server. The server can initiate their own streams as well. And it says, hey, I want bidirectional. I want directional. I want unidirectional. I want datagram. I just want UDP. UDP is wrong. It's called HTTP datagram, right? And I want that stream to be unreliable. Don't try to order the packets. Whatever I send, it's an audio or a video, whatever. And I want it to arrive whatever the net decides. If the internet decides to reach out of order, let it arrive out of order. I will deal with the out of order packets, frames in this case, and I'll deal with them as an application. I know what I'm doing. I'm an application developer. If I receive something that I know is out of order, I'll deal with it. Maybe I'll just show it to the user if it's a part of the video. Maybe I'll skip a frame. Maybe I'll buffer and wait for the order. So you have no idea, guys, how powerful control is for application developers. Never ever give up control. Control and the flexibility to have the power to control these things is priceless. Having magic box that does everything for you, and you have absolutely no idea what it's doing, and you have no control over what's doing, is a nightmare for developers. You see, that's why Postgres gives you 1,000 knob and 1,000 tuning parameter, because they know the software databases are complex. There are thousands of tuning parameters. There's thousands of use cases, right? You want to adjust the wall size. You want to adjust how often you checkpoint. You want to adjust all other parameters, like how often do you vacuum, how fast and slow things are. It depends on your workload. I know I'm going databases, but it's all coding, all application logic at the end of the day, right? But yeah, the power behind WebTransport is this ability to have streams. Now, the question that kind of ask itself here is just, wait a minute, Hussein, like, what does that mean? Like, okay, you started this discussion was saying that the web is all HTTP. Now we're introducing a new protocol. True. That is why WebTransport is technically available, as far as I know, in 2 flavors. You can build WebRTC, I keep saying WebTransport over HTTP2. There is a draft for that. And there is a WebTransport over HTTP3. And surprisingly, they are very different. I'm reading those, I'm getting really confused because of just the complexity. Yeah, and those are 2 different teams, seems like. And even reading the verbiage is so different. It's like almost these 2 don't talk to each other, whoever wrote those 2 RFCs. It just feels like that, at least to me. Yeah. So naturally speaking, WebTransport doesn't really make sense on HTTP1 because it doesn't have the idea of streams. Well, unless you want to build it on top of a single connection, but that doesn't make any sense, right? Okay. So there is no WebTransport for HTTP1. You know, if you want that, just use WebSockets. Well, and if you use that, maybe there is, because I didn't see that option, right? But it'll be weird because it will be a single stream of whatever, one thing only, right? And naturally, both HTTP2 and HTTP1, well, that's HTTP1. Let's not talk about that, right? HTTP2, on the other hand, will give you the ability for bidirectional. You can create a bidirectional. You can create directional, but there is no unreliable datagrams for WebTransport on top of HTTP2. Naturally speaking, because HTTP2 is on top of TCP, you have to go order. That is the one main reason why HTTP3 was invented, right? To solve the head of line blocking problem that is available in HTTP2, right? While cool, we have streams demultiplexing, you know, all these requests demultiplexing into multiple streams. Beautiful, right? But they kind of have to go in order of the order they are sent in, because we are at the mercy of, technically, at the kernel TCP stack, TCP IP stack, the OS kernel there. Because when we send these requests, which will turn into these streams, which will turn into frames, which will, these frames, again, we're still in the application layer 7, right? All this goes into the kernel, and then we're either UDP or we're either TCP. If you're quick, we're UDP. If we're TCP, if we're HTTP2 or HTTP1, then we're TCP, and that's the stack for the kernel. And these are just packets, right? At the end of the day, segments to be specific, TCP. And then the kernel just deals with them as segments, right? And of course, the TLS may come a little bit earlier than that to encrypt the content and stuff. But yeah, we're at the mercy of that layer, and we have no control at all. That stuff. Well, what I want to finally talk about is how do we actually establish this? You know, in HTTP1 and WebSocket days, we have the idea of literally something called upgrade. You know, we have a request called HTTP. Right. Yeah. So it is in HTTP 1.1. It is literally just a GET request with a specific header called connection upgrade, and you specify what do you want to upgrade to, and you specify, hey, I want to upgrade header, and this is the WebSocket. We cannot really do this in HTTP2 or HTTP3, and the reason is because that definition is the connection level, right? Which is which is really expensive. I don't want to upgrade my whole connection to WebTransport. No, I still want to use the connection for other normal request responses, like normal HTTP3 request responses. Someone visited the page. I still want to use this connection for this. Okay? So this is how powerful this concept is. We're overusing just a single connection. If you're connected to one domain, right, on port 443, you can still click on links, right? Send GET request, send POST request normally. You can have a web transport on the same connection, a session with 5 web transport streams on that connection. And you can have a single server sent events on the same connection as another stream, right? And as long as the client initiated them, they will be, I keep forgetting this. I think in HTTP3, it will be client initiated is odd numbered streams. So 1, 3, I think 1 is reserved. So 3, 5, 7. And server is even. So 2, 4, 8. Because the server can initiate stuff as well, right? Yeah. That was back in the day when HTTP2 push was a thing, which is, it's dead, of course. Because like we thought it's going to be a good idea, but it turns out it's not. It's just 103 early hints is, I think it's a better, right? You never shove anything to the client. I'm going all over the place, but Kafka realized this the hard way, right? I think they made a good decision by they when in their consumer subscription model with Kafka, Apache Kafka, they had choices. Should we push the data and shove it in the throat of the consumer and the client the moment we get something on the partition, or should the client pull for it, right? They finally decided to go with the long polling model, which is brilliant, right? And this is a lesson we learned with HTTP2. HTTP2 push was a model that said, hey, you can make a request, and here, because you're going to need this CSS and this JavaScript and this, and I know you're going to need all this, here, consume all of it. And it was bad. This also was bad because the client sometimes, hey, why did you push this to me? I have it cached. Server, never push stuff that I have it cached. God damn it, server. Or sometimes it's just the client is weak. It's a very lightweight client that doesn't really have the bandwidth or CPU power to take all these pushed resources. You might say, really? You can't handle another CSS? There is a difference between something getting shoved down your throat versus something you actually asked for. Big difference. You only see these, workloads at the production level. Push is really dangerous. That's why YouTube can never figure out notifications. It's like push notifications is one of the hardest thing to do. Like we think why do you think YouTube has like 700 options for notifications? Because they can't get it right. Because push, you cannot shove anything down the client throat because you have no idea if they can take it. That's why some notification, I got a notification, I published the video, but it's like, you think Mr. Beast have like 70 million subscriber or more? You think YouTube's gonna send 70 million push notification across the world? No way they can do that. Even if you put them in a loop, even if you created 1,000 threads to send all of them, it cannot scale. Push just doesn't scale in general. All right, I know I'm going all of it, but if even that's something to understand with the WebTransport protocol, because WebTransport, you can understand that if you decide to go with a bidirectional route, you better understand that the server might push more things that you can't handle. And browsers, of course, has some sort of throttling. They understand that, they limit there's a lot of configuration in the WebTransport protocol to limit the flow control. It's a really, deep things. All right, so I know I went all over the place, but what I started this thread by saying, HTTP 1.1 to upgrade the connection. You say, hey, I just sent a GET request, and I know I sent it on a TCP connection. Let's upgrade this connection now. From now on, this whole thing is now just WebSocket waste, right? So HTTP 2 and 3, specifically, there's a specific RFC called 8441, which is bootstrapping WebSockets on HTTP 2. That was the idea of this. It was designed such that the idea was, it's like, hey, we can't really do this upgrade thing on HTTP 2. It's just a waste because HTTP 2, I don't want to establish another TCP connection for HTTP 2. The idea of HTTP 2 is to have multiple streams. Now you're saying that I have to reserve all this connection for your WebSocket stuff or WebTransport thing? No. So there's another RFC that got spun up, and I talked about it in this channel actually, 8441, where it says, hey, let's create a mechanism to only take one stream and have that stream as a WebSocket stream, right? That's where the extended connect method was invented, where it says, hey, I'm going to send you, let's establish the CP normally. Then I'm going to send you a connect method. That's a special connect HTTP method. Yeah. And then in the connect request, I'm going to say, hey, let's use this stream. I want you to upgrade to WebSocket. And I want to support this scheme, HTTPS, for example. And I want this and this and that. And in that, if the server supports it, it's going to reply with 200 OK. And then they agree on, say, all right, so there is, it depends on how you implemented it right here. So the client will say, all right, let's now, we have established this stream from now on is a WebSocket stream. Or like the WebSocket WebTransport. Or what the WebTransport guys do is they use the stream ID that was used for the connect method, because the connect was sent on a stream. That stream ID is now reserved as a session ID, is now treated as a session ID for that WebTransport. And that's how HTTP 3 WebTransport and HTTP 2, I think, works the same thing. So that stream ID is playing dual role as a stream and also as a session ID. So they use that to identify and create new streams. So you can create new streams. And of course, you tell me, hey, that's my session, right? And theoretically speaking, you can create many sessions on the same connection, right? And those sessions have their own authentication, they are dedicated, although they're going to the same server technically. And I don't see why not, but you can proxy WebTransport, right? You can terminate TLS. You can understand those frames. God, it's going to be difficult, but I didn't see any proxy support WebTransport yet, right? At a layer 7, because at a layer 4 is easy. Just that whole anything you send goes to the upstream server, right? But as a layer 7, you terminate, you understand how to read them, and you forward those frames to the dedicated server. And it's really tough though, because the server, the backend upstream servers better understand how to proxy, how to not save any particular state per se, right? About the connection, right? But decode the frames independently. And frankly speaking, I don't know if that's possible, right? It's just didn't have time to think about it. It just came up to my mind right now. But yeah, WebTransport, guys. If you're on top of HTTP3, you have all the beautiful things. We get bidirectional, unidirectional, and unreliable delivery, right in your app. So with that, we throw some controversy here that I think the WebTransport protocol will eventually replace WebRTC. It will eventually replace, eventually could be 20 years. Who knows? Who knows? WebRTC could fail in 3 years because nobody uses it. But I know we like to speculate here. Right? I think it will replace WebRTC, but that's my thought. I think it will replace gRPC. I know. Sorry. Yeah. And I think it will replace, well, WebSockets, right? Just all of these protocols just squeezed there. Let me know in the comment section. What do you think? Call me out. And I'll see you in the next one. Take care.